Hello, I'm Martin Cherny from xbim, and that's the second part of the video for software developers who want to put BIM in their web or cloud projects. In previous part, we are looking at IFC as a standard. We are looking at xbim Toolkit and how to put together a proof of concept, which will make you happy, probably, but you may find some issues when it comes to production. And that is what today part 2 is about. It's about how to take it to production, how to target scalability of your platform, of your solution. The last part will be looking at an alternative service which we developed, which you can use to simplify your deployment and your code base. So last time we had a look at this very simple proof of concept. It takes 10 lines of code with xbim Toolkit to convert from IFC to visual representation for online presentation. And it takes just about 3 lines of JavaScript to render it in the browser. And there you go. But this is just about geometry, right? We'll have a look at the semantic data sometimes else. And also, once you put a bigger file in there, it probably you'll notice that you'll hear the fans of your computer going on. And when you have a look at the resource consumption even on your local development machine, you'll see that it actually goes to 100% of the CPU. And real-world BIM models are often quite large. It's not rare to see models over 500 megabytes. And xbim Toolkit is actually doing quite a lot of work for you. It's designed to process all the data as quickly as possible, so it takes all the resources it can take, which is great, right? It's as fast as it can be. At the same time, it actually takes all the resources, so other conversions cannot really run at the same time in parallel. And if you run this as part of your web API or of your application, it actually blocks the application. You effectively cause yourself a denial of service, which is probably not what you want to do. Now, this is not an issue of the toolkit, right? You may try other libraries or other toolkits to process IFC files. You'll hit exactly the same issue because it is the nature of the BIM data. It's very condensed, it's very rich, its geometry model is potentially quite complicated, and when you want to process it all to simple triangles and colors to get the graphic representation, it just takes resources, it takes time. So as you get closer to production, you will realize that you actually need to split them. You need to split this conversion functionality from your actual core application. And this is quite likely what you will end up with, right? There are still these 10 lines of code here in the core, in the processing unit. But that gets isolated now. So there is actually your application, and there is a processing in between. There is a message queue, because processing is now triggered by a message that must be light-wide. But IFC file itself is quite large, so it wouldn't probably fit in there. So it will have to go to a blob storage or some kind of file storage, something you can share, some space you can share between your application and the actual processing unit. Some other messages need to be sent back from your processing unit back to your application, to your user, because you want some kind of feedback about what's happening, the progress, or signal the failure. So there needs to be some other message, not queue, other message channel. At the same time, while the processing unit will probably be designed to be idempotent, in certain parts it will probably require some state management, so you'll need some NoSQL storage or table storage, or at least a Redis cache or something else to actually keep the state of that processing to bring it together. You'll also want some logging service, because now it's not a black box, but it is a detached box from your main application, so you'll want logging service to see what's happening, so you can actually fix any issues as they come. You see all the warnings, etc., because it will not be visible in the front in the main application itself. You'll also probably want to deploy some auto scaling. There are many ways to do this. It needs to be configured and it needs to be maintained, right? So at the end of the day, this is again not specific to BIM, it's not specific to the toolkit. This is normal thing you would do for any heavy processing, and processing of BIM models in general is a resource intensive task. There isn't much you can do about that. So taking it from your simple design, you see that this has evolved into something much more complex and complicated, but probably and most likely necessary if you want to bring it to production. Now, that has been a journey, right? It's quite a leap to go from that simple proof of concept to something as complex as this cloud deployment. Now, we at xbim have gone through that journey itself ourselves. That's why we built Flex service, which I'll talk about in the next part of this video. It's platform neutral, language agnostic, and it would handle most of this stuff for you. So you can go back to simple, and instead of maintaining all the complex infrastructure, which you can just call a few simple API calls. But that'll be in part 3. So go there, stay with us, and have a nice day. Goodbye.